All right, so to finish off that very last one, after we found our answer, because we could plug in this, but we couldn't plug in the x, and we found out dy dt, um, use word answers. So we're like, okay, the shadow is shrinking because it's a negative at negative 4 feet per second, which makes sense. As you walk closer to a light, your shadow is going to shrink and shrink. But what's weird is it's not the same rate that your distance to the light post changes. All right, let's try another one. We got two more to try here. Hopefully we can cruise through these and get the hang of it. But you're going to start to see every problem is different. So there's no way I can do an example of every problem you could get. But what I want you to start to get is just the feel of how to do these problems. So first, we're going to read it. All right, so there's a TV show about unnatural experiences and nauseating aliens claims to have photographed a UFO as it flies overhead. At a constant altitude, that's important, it's constant, of 3 miles, and a constant speed. We don't know what the speed is. They state that they took the photo, which resembles a very blurry cigar, including what appears to be a cigar label, at the instant after the UFO had already flown horizontally 4 miles. Now that sounds like particular information, but we'll look at that later. Past the point directly above them. So you got a person, you got with a camera, you got a UFO that's flying horizontally. The distance between the photographer and the UFO was growing at a speed of 384 miles per hour. Determine the speed that the UFO or cigar was traveling. Okay, so we're going to draw a picture of that. Well, there's one. Yeah, one is read the problem. Step 2 is draw the picture, right? So step 2, when I draw this picture, I'm going to have like a person right here, right? They got a camera. We'll make it kind of an old school camera. Got our lens and this, right? Classic. Pretty good though. And then the UFO is flying horizontally. It's going this way. So we got our UFO over here. We got boom, right? Ooh, looks like a fried egg or a UFO. Maybe I'll give it little legs. There we go. Not bad. Not bad. Good job, self. We're going to color that in so you can't see. All right. Anyway, so we got our UFO flying. Now, they talk about your distance to the UFO, and they talk about when it was directly overhead. If you draw all this stuff in, you should see a right triangle, because distance straight above his head. So that's good news. I want to know if I can put, because I have to put variables on all these sides, but I want to know if I can put any number in here. And the fact that it's flying at a constant altitude of 3 miles means I can write 3 miles here. I'm not allowed to put the 4 miles past because that's not always going to be 4 miles. This thing's flying, right? So it's 4 miles and it's 5 miles and 6 miles. So it's got all the other information is particular. Like this 384 miles per hour was the distance between them growing. Well, that's a rate. So basically, I'm going to put an X here and a Y here because I don't know those, but I'm allowed to put a 3 in here. That takes a little getting used to. Step 3 is write a general equation for this. So if I wrote a general equation for this, it's a right triangle, and I'm talking about side lengths. Well, we have a formula for that. Pythagorean theorem, right? This is a Pythagorean theorem problem. Last problem I would have classified as a similar triangles kind of problem. This one is a Pythagorean theorem type problem.
Hello?
Oh, hold on. Had a little Google Meet issue there. So Pythagorean theorem is a squared plus b squared equals c squared, but I want to use these numbers. So I want to make sure I do my leg squared plus my other leg squared equals my hypotenuse squared, right? Okay. So there's my Pythagorean theorem. Super easy formula, right? And step 4 is to take the derivative, differentiate with respect to time. So step 4 is take the derivative implicitly. So I'm going to d over dt everything. Okay, so I'm going to do that to all parts of this. I'm going to say, okay, d over dt. I'm going to say 3 squared is 9. And I'm going to do that to every piece. And remember, you have to pay a penalty if the letters don't match, and none of the letters match. But the derivative of a constant is still 0, so that goes away. The derivative of x squared is 2x, but I have an x prime, that penalty. You can either write dx dt, or you can write x prime. I don't mind either way. And then here, I'm going to do 2y, y prime. You have a penalty because the letters don't match. Now, here's something to notice. I'm glad we had this problem second, because what do these things mean? Because that's my derivative. But what regular x means is x is actually the horizontal distance. What x prime means is the rate or speed horizontally. Right? What does regular y mean? Regular y is actually the diagonal distance. What does y prime mean? Y prime is the rate of change of the diagonal distance. So that is the rate diagonal is changing. That's important to know when we go to plug stuff in. So step 5 is find the particular info. Now this problem, 3 we were allowed to use because it's constant the whole time. We're going to have our particular info over here in a box. So what is this 4 miles? It had already flown horizontally 4 miles at a particular time. So that would be my distance this way. So a regular x equals 4 miles. Okay. And then here, the distance between photographer and UFO was growing. That sounds like a rate. At a speed of 384. So that's this direct distance between them. Okay. So it's like if the photographer had a radar gun, they would be measuring this speed that they're changing between them. It's not actually the speed that the horizontal distance is flying. It's not the speed of the UFO. It's actually the rate at which the distance between them is flying. So if you had a radar gun, you would be actually measuring how far it's moving away from you, not how fast it's moving. So that is y prime is 384 miles per hour. Okay. So the question is, determine the speed of the UFO. When you read that, that's basically asking you to find x prime. So yeah. All right. Let's check this out real quick. Okay, so that was step 5. Step 6 is plug this stuff in here. And what you're going to see is sometimes you run into this weird issue. So this is our plug-in. I like to show you some examples that run into some common issues. All right, so when I plug stuff in, I know what to put in for x. So there's 2, and x is my horizontal distance, 4 miles. And then I have x prime, which I'm solving for, because that's what I want to know, horizontal speed. And it's 2. The problem is I don't know what y is yet, but I do know what y prime is. And I'll show you 384 miles per hour. I'll show you we actually can figure out what y is, because I couldn't put a number in up here, right? Because y is changing. It's all, as this thing moves, it keeps getting longer and longer, right? Well, at this particular time, when I tell you you have particular info of this being 4 miles, and I already know this is 3 miles, at that particular time, you can actually find out what y is. So I can add that into particular information since I need it. Usually I don't do this step until I get down here and I realize, wait a second, I need to know that if I'm going to solve this problem. So you can do a little Pythagorean theorem at that particular time and find out what y is. Not forever, but what y is right then. So you go 3 squared plus 4 squared equals y squared. Or you know your Pythagorean triples and you could have gotten this answer. Y is 5, because you're going to square root 25. Okay, so it's a 3, 4, 5 triangle. So at the time, this is 3. At a particular time when that is 4, this is particularly 5. It's not always 5, just at that time. Boom. Now we have everything we need to solve this. So we're going to plug in and solve. So that'll be 8x prime equals 10 times 384. Okay, 8x prime equals 3840. X prime equals whatever 3840 divided by 8 is. And this will be the rate at which x is changing. So 3840 divided by 8, boom, 480. And that would be miles per hour. Okay, so this is our rate. So number 7 is circle your answer and give it word answers, right? So I would say the horizontal speed of the UFO is 480 miles per hour. Okay, so if you happen to be way up here, if you were in the cockpit and you looked at your speed and your alien life form also used miles, which is insane because miles is a terrible system. But the speedometer would read through 480. And this checks out mentally if you think about it. You know how, the hypotenuse is always longer, so it makes sense that the distance it's going away from this photographer, if they had a radar gun, is not as fast as it's streaking across the sky because they have a longer distance. So it would appear that they're moving away slower even though they're going 480 this way. Anyway, that's how you do that problem. I'll come back in another video for our last problem. Good times. Talk to you later.